Hi everyone, it's David, and in this video we're going to be going through Uniswap and how to integrate it into our external applications. So if we look at the Uniswap landing page, what it tries to explain to us about the protocol is that it's a EMM protocol that basically allows users to swap one asset for another asset. So it's basically like permissionless swapping, rather than, using centralized exchanges that, make it order books. In this case, you have, liquidity pools that enable easy swapping, basically. Here, they add extra information. They also touch on like the fact that, we now have the uni chain and the rest of them. So just like a little bit of backstory of what it is, there are two sides to it. So on the front, we do have the swap, right? It allows you to go from like Ethereum to whatever other currency or whatever other token, or like, USDC to whichever other ERC20 token, let's say WBTC. And you also have like the pools. This means like you have, the swap side, which is the trade side of things, and you do have the pool side of things. So the swap side of things, which you mentioned earlier, covers how to convert one asset to another asset, ERC20 tokens in particular, right? And on the pool side of things, right, it basically shows us how those trades are facilitated. So if you think about it, there's the pool that has equal, assets, equal amount of assets, right? So you have the ETH USDT pool, you have the WBTC USDC. We can look at other pools, right here. So we can see, why it's USDC. So participants put, assets into this pool and they get back APRs, right? And this returns incentivizes them to keep the pools alive, which then enables the transaction. So the swap, you can also decide to add liquidity to a particular pool. Let's say it's, USDT, right? And you can see different feeds here. So you can see you want it in the pool that has, 0.05 or, 0.03, fees. So basically these fees are what accrues together and, are returned back to the LPs, right? And if you continue, you get to see, min price, max price, you select the amounts of tokens. So let's say you want to select one ETH. You're also putting in, 4,517, USDT, right? So from there you connect your wallet and you complete the transaction, right? So on the engineering side of things, I already created a playground, talking about like the V4 contracts and what they're like. So by default, this playground is simulation. That's the simulated playground. So we have like the pool manager contract. First of all, okay, so I briefly dropped, the definition of like the V4 contract, the V4 protocol, the PSPS system, for exchanging ERC20 tokens on the Ethereum blockchain. And also it also works on like other IBM chains. Protocol is implemented, it's a persistent, non-upgradable contract, to prioritize censorship resistance. So the pool manager is basically a contract that manages like all the pools. It allows you to create, manage trading pools, handle swaps and all that stuff. You can also take a look at it, call folks. These are like the major methods here. But the ones we'll be using the most will be like, the position manager. But let's go through each of them. We'll get to the position manager in a bit. So for the position descriptor, what you have is just a simple contract that helps you generate, metadata or SVG images for like, liquidity provision NFTs. So basically the idea, like when you create, you mint a position into a liquidity pool, meaning the pool exists and you decide to like, the first time you decide to like invest in it, it's sort of like what it means as an NFT as a form of validation that you just minted a position in this pool, right? And this creates a visual representation of, your LP position, NFT, right? The NFT for that position in that contract, in that pool rather. So it generates JSON metadata, shows pool information, all that stuff, really. So the position manager contract allows us to manage liquidity position. So in case of you invest in the pool, right? You mint a position into that pool. You create an NFT, but that's by the way. But yes, you create a position in that pool. Then within that pool, you can basically add more liquidity, remove liquidity, take out your fees if you just want the fees out and you still want your position in that pool to remain, or you can just burn your position and just take everything out. Right. So that's all of that action can be done with your position manager. So basically means, your position in that pool, you're just trying to, manipulate it and, change stuff and do what's necessary for yourself. Then you have the quota contract. So this quota contract is used to get quotes. So before you make a swap. So now we've spoken about the position manager and all of that, which happens on the pool side of things. But now on the on the swap side of things, which is the trade side of things, right? You have something called the quota. So the quota is the contract that allows you to get price for coal. So you want to convert, USDT to Bitcoin, or you want to convert Bitcoin to USDT, and you want to know the current quotes, the current price. This basically allows you to do it, right? So you say it provides price quotes without executing transactions, simulate swaps, all of this stuff. Then you have something called state view. So state view allows you to read pool data efficiently. So let's say you want to know if a pool even exists in the first place, right? The state view allows you to check it, check that pool using the pool ID. We'll get to that in a bit. And you're able to get back prices, the liquidity within the pool, the information about liquidity and stuff like that. So that's mainly what the state view is. Then you have the universal router, which basically allows you to perform, swaps, right? So you basically, each of these methods have different use cases for performing swap, but they all perform swaps, right? So that's it down here. So sorry, I'll bring the quote. So for the universal router, rather, let's execute the swap and get back a response, all of that. So for permit 2 is basically just allows you to get authorization for approvals on your token, for the contract to basically spend the token, right? So we'll get into the approval bit, because this is essential while you're trying to perform swaps, from one token up to another. Because in this case, you'd have to get debited, right, on one token, then you receive the equivalent token into your wallet. Right. So that's what the permit 2 does. And we have here the USDT contract and the BTC contract, which we want to use in this playground. So if we go to the actions, the first thing we want to do is get quotes. Meaning in this action, what's going on is we're trying to get quotes for a particular currency swap. And just know, okay, what is the equivalent asset we're going to receive, in the case of actually performing this swap. So here, we bring in all of our methods and variables from ethers. This is automatically injected here. You have the quota contract address, you have the quota ABI, gotten from the Bonadox, the contract, the quota. Because within this playground, we've been able to get out, the contract addresses and ABIs, because everything's already within the playground. We have variables, the private key, that is here in the variables. So we have the private key as an environment variable, and it's initialized here. So you have the sender signer, which is initialized using this private key rather. And here we have our config. So within our config, we have the pool key. So we have, this is the WBTC address and this is the USDT address. We didn't bring it into this particular action, but it can also be brought in, similarly as the quota address, just in case you want to do that. So here we have the fee. So 0.3% fee, which we have here. We're trying to specify, the pool that we want to actually get this quote on. So we go, okay, here we have it, 0.3% fee, tick spacing 60 hooks, no hooks, right? We have 0 for 1 true, the amount in that we want to check for WBTC, is 3 BTCs, 3 WBTCs, amount minimum just 0 because we're just trying to get we don't get quotes. You could actually also add value there just to, or it would be in using decimal of the token we want to get back. So this is 8 because the decimal on WBTC is 8, right? So initialize our quota contract, and here say get the quotes exact inputs, the static call. So static call on the Ethers, let's go to the Ethers documentation. It's sort of like simulate a behavior, right? So so we're using the V6 right now. Let's simulate a transaction, a method call, right? So call the contract method as, but return the results without, dereferencing. So basically that's what it does. So basically static call allows us to perform transactions by not changing, or asking the node to not change, to act like it's not state changing. So that transaction feels like a read method, right? So that's what we're doing in this case. I'm using the quotas contract. So we come here and do quotas contract dot quote exact input single, right, dot static call. So using this, we're able to do passing the pool key we mentioned earlier in the 0 for 1 exact amount hook data, and we're able to log the quoted amount out, dot amount out, which is what we are trying to get. So for context, I'm using a build beer sandbox, which is a forked network from the ETH chain. So it's basically like a custom fork network. And what we'll get is when this runs, we do get back the value. So you have to ignore this decimal points, this 0 decimal points, because the price on this fork network is much lower than what you have here. That's why this is happening. But yes, you're getting back 345,783 and love like other figures as the response from this particular swap. So you're putting like 3 Bitcoin, you're getting back in real life, on real network, it's about 345,783 USDT based on the time this was done. But obviously, if you are using an actual provider on the main network, right, you will get back the correct figures, right? So you have to keep that in mind while getting quotes before performing the actual swap. So many times you have to get quotes first, then perform the swap after. You can also take a look at, I know QuickNote has a few other write-ups that explain this, the quote and the swap, but theirs is for the V3 contract. So this is the V4 contract that we're using for this demo. I would also be dropping information like 2 articles. I think I have one from QuickNote and I have one that explains static calls better. So you can also like understand what static calls, what they do in this case. So secondly, we want to check if a pool exists, right? So the get quote and the swap basically work together, right? But at the same time, you might want to check if a pool exists before you create a pool, right? Let's say you want to create a pool, and you don't know if it exists, maybe on a different fee, right? You want a new pool with a different fee, and all of that, right? So this action basically helps you check what, if a pool exists, and also return like information like, the liquidity on that pool and the rest of all that. So what we're doing here is, as usual, we get back our signer, we initialize our contracts, including, port manager, state view, all of that stuff. So first, we're trying to check if WBTC and USDT exist. So we have this, we determine the currency order, and so what we do is check for the existence. We get out the big int or that address, just to ensure that is in the right order, right? Because a USDT WBTC pool is different from like a WBTC USDT pool, and just like ensure that there is a form of consistency in what the pools are for each pair. We have this one here, and we have it, arranged in this way. And obviously we can log that just to, it's done, we then log out the currency order, just know which one's lower or which one's higher. So like if it's this address, write out WBTC, if not USDT, similarly to the higher. So we create the pool key as we did earlier. And we also like log all of this, just know where we are within the logic. Here we calculate the pool ID. So the pool ID is basically a unique pool ID, a unique ID for each pool pair or each currency pair. So we also log out the ID because that'll be essential to check if the pool exists. Right, so we have the slot 0, we pass in the ID, so you get back slot 0, which we then use to like get information about that pool. Right? So here, we go through all of this and square price x96, we get back the price, and within here we're able to get back the price for each of the tokens in the pair. Right, so we have the one WBTC equals this price, the current price for one USDT. So here we also check if there's an error. We know if the pool exists or is not even initialized at all. But if not, we should get back the price of each assets within the pool. So we also like check liquidity of that pool. So similarly, we have, date view dot get liquidity for that particular pool ID. We get back, this liquidity. Then, the string, if it's 0, it doesn't have liquidity. If it's not 0, it then returns that, the pool is active. So liquidity error also, similarly, you can also do that. For method 3, we're checking the fee growth data, and we can also do that. So these are like 3 ways you can like check out if a pool exists. And there's also the case of you can also check for different tick spacing and and fees to know if that pool exists. So, similarly, you get the pool ID, then you check the same way we've checked previously. So I think here, what do we use to check? We use the get slot 0 to check if the pool exists. So if you run this, you should get back all of the necessary information that shows the WPTC and USDT pool does exist. So yeah, you do exist for these different price points, including 0.05, 0.01, 0.3, 1%. Because basically, if you come here, you should be able to see polls. Yeah, here we go. I'm not sure this is. Just put WPTC/USDT poll. Right, so this is 0.05 poll, I believe. Right, so that just shows you how to get information about certain polls using the state view contract. And finally, we're going to be taking a look at the swap. So just quickly go over this. We get our signer, initialize all of our contracts using bonadocs.contracts.contract name. Right, so on that proof token, we have a dedicated function to that, where we initialize the token contract that we want to swap, which is the WBTC. We need to create approvals for just one token, because we're approving one to be debited from our account, and the other currency would be added to the account. So we have the permit to contract, right? So here, this is also initialized using the address, the ABI, the signer, and we get out the decimals. We create approvals for the permit to address, as you can see here, max approval, permit to address for this token contract. And we then take that permit to contract, then approve the WBTC to be spent by the universal router address. So the universal router contract is what we'll be using to perform the swap. So we then go ahead to define the amount, the router also, right, is then initialized the router contract. We log all of these values. We define our pool key, which is a standard at this point. We then encode the command, right, for swap exact in, right? So if you go into the documentation, you would see what that is on the variables here. So if we check swap exact in single, we go to the docs. Under actions, right? Swap exact. Yeah, swap exact in single. You can see it here. Hold on. So we encode our command from here. So you have swap exact in single for the universal contracts. For actions, we also write it out here, where you have swap exact in single, settle all, take all, right? After that has been done, so for each of this X encoded values, you can take a look here under actions and find the correct values to use for whatever you want to implement. And under exact input single params, we also then encode our values. So you have the pool key, Then you have 0 for 1, you have amount in, amount out minimum, all of that, all the way to the hook data. So we added our pool key and we added this amount in, which is, 1, amount out minimum 0, hook data, all of that. And within our params here, we add our exact params that we already have here, right? We put in within these params. So under params here, we are able to, also get back the currency address, which is the UBTC address, and the amount we hope to swap. And also we have the currency one, which is the amount we hope to receive, and minimum amount. So inputs is also encoded, actions and params. So we click on this, takes us back here. So all of these params that are under the array, they're also added here. They also added here and actions. So all of this are now being encoded into inputs and the deadline, which we made a 5-minute expiry. So here, finally, we can then do router.execute, commands, inputs, deadline. I just have like a value 0 because it's not a 8 swap. Then we wait, then, if successful, we say swap successful. Right. So if we run this, we're also able to hopefully perfect the swap and have it. And here, our swap successful. So if we go to the build beer, okay, here I believe this is it. Let's open it and check. So we see for one RASBT token, we are able to get back 115,330 USDT, right? So that way we can see the exact value we're getting back here. So with that shows us the exact swap we are making and the amount we're getting back in USDT. So I think we've covered fully like the user facing side of, which is the trade facing side again of these transactions with the Uniswap v4 contract. So we are able to understand how swap happens. Before the swap, you get the quote first before the swap, and you should be able to get back, the transaction you need to get back. You can also check for the pool existence. Obviously, like if you go into documentation, you're also able to find things like, you want to get a particular amount back from the so for instance, we're going from RASBTC to USDT, right? If you want to get a particular amount of USDT back, you can also impute that, into the params, right? To get all of that back. So you can also check a look at documentation. So there's also the SDK, but we didn't use the SDK. We just did the transaction directly with the contract, right? But they also have the SDK that abstracts a few things, in case we want to check that out also. So yeah, that's a good coverage on the V4 contract. You also things like hooks. So hooks are basically external contracts. So from the point of creating a pool, right, you can add hooks that basically tell the pool what to do based on certain life cycles. So let's say before pool creation and before swap, right, call this external contract to do this and this. It's sort of like, you have a method somewhere, right, and you need that method to be called when an action happens on your pool, right, that you created. So the hook contract have like methods that have specific names, like maybe, initialize contract, it's already initialize pool, and all of that stuff. That basically calls that external contract, that hook contract, and tells it, what to do, basically. So in case maybe you want to add certain incentives for people that perform swaps on your pool, you can do that, right? Maybe credit their address with a particular asset, like a reward asset or whichever the case may be. It's flexible enough to allow you to perform whatever actions you need to perform. So I think that one of the biggest push with the hook feature within the V4 contract, right? So that's something we can also check out. So we come here, we would see hooks. So for instance, swap hooks. So swaps on common interaction, as we have shown. When it comes to the swap, there are two hook functions available to extend this behavior. So before swap and after swap. So this will be the name of the methods on your hook contract, right? So what happens in real life is like you basically add, once you deploy your contract, you add the contract address to your pool creation params, right? So I mentioned the functions or like the methods on the hook contract are called before or after a swap is executed on a pool. It shows you how to go through the params for all of that. So we have all of our contract, our swap hook. We basically write all of this stuff before swap, which is the method. So shows that every time before a swap is executed in a pool, before swap count for that pool will be incremented by 1, right? So you're trying to count how many times this user perform the swap, or is it how many times his swap hasn't performed by anyone on that pool, I believe. Yeah, I believe so. So before swap, when triggering the function, there are some parameters you can make use of to customize or extend the behavior of the swap. So we have the sender, typically a swap browser, the key for the pool, the parameters for the swap, the arbitrary data. So it means that you can actually also count how many times a particular sender or a particular user performing a swap using the params. After swap, you're also able to execute a particular external contract method, and yeah, incremented by 1. This is like a simple hook contract. Then this whole contract is then added when you're creating the pool. So similarly, you also have things like before add liquidity, after add liquidity, you have to ensure that all of these names are the same with the ones on your hook contracts, right? Because they are standard names. You can't change them. So, called on or before liquidity is added, you go through the params and all of that. Similarly, you have to set up the contract, you can go through all of this, and then, hook it up to your actual contract. So here we'll talk about the async swap hooks. It means developers can replace Uniswap's internal core logic on how to perform swap, and to imagine use cases can be possible with custom accounting. So yeah, we also have the deployment addresses which we used within the playground, so you can also check it out. So this is one for Ethereum, which is what this playground is on, and Unichain, Optimism Base, and all of this other chains, right? So here you have everything you need to integrate on top of Uniswap's smart contracts and test stuff out.